All right, let's jump right in. What if you could build an AI that doesn't just think, but actually acts in the world? Today, we're going to do more than just talk about it. We are going to dissect the blueprint. We're exploring how to build these smart autonomous agents using Python, and we're going to peel back every single layer to see what makes them tick. I mean, really think about that for a second. This is a huge leap. We're moving way beyond simple chatbots that just spit out information. We're talking about AI systems that can book your flights, run in-depth market research, or even write and deploy code all by themselves. That is the real power of agentic AI. So, what even is an agent? Honestly, it helps to think of it less like a piece of software and more like a digital organism. You know, just like a living thing, an AI agent has a brain for thinking, a nervous system for all its communication, and hands and feet to interact with the world around it. And today, that's exactly what we're going to do. We're performing a full dissection on this digital life form to see how all those parts work together. So our little anatomical tour is going to take us through 5 critical systems. We'll start with the agent's brain. That's where all the magic of planning and delegating happens. Then we'll trace its nervous system. We'll see how its hands and feet take action, and we'll even dive into its memory. And to wrap it all up, we'll learn how to give it a full health check, just to make sure our agent is ready for the real world.
Okay, first up, the cognitive center, the agent's brain. Now you can think of this as the control tower, but it is not a micromanager. Its main job isn't to do all the work itself. Nope. Its job is to understand a big, complex goal, break it down into smaller, bite-sized tasks, and then delegate those tasks to a whole team of specialized agents.
And that's the crucial part right there, teamwork. Let's say you have a task like create a market analysis report. Well, the brain acts like a project manager. It might get a researcher agent to go find the latest financial data, a writer agent to draft the report, and maybe even a critic agent to review that draft for accuracy. This whole multi-agent approach is where the real power is, and it's all coordinated by a Python framework.
Now, when we talk about the brain, the choice of framework is super interesting. Check this out. If you need to build a prototype like right now, just to show off an idea, Crew AI is your best friend. It gets 5 stars on speed. But for a real production system, where you need to see exactly what's going on under the hood, LangGraph is the undisputed king. It gets top marks in observability. And just a quick heads up, you'll notice AutoGen here, but it's in maintenance mode now, which makes it a bit of a risky bet for new, long-term projects.
So the key takeaway here is pretty simple. Use Crew AI when you need to move fast and prototype, and go with LangGraph for your serious production level work. It's a simple rule of thumb, but it'll save you a ton of headaches down the line. It's all about picking the right tool for the job.
Okay, so we've got a brilliant brain, but that brain is totally useless if it can't communicate clearly with the rest of its body, right? The commands would just be a jumbled mess. And that is where the nervous system comes in. It makes sure every single message passed between the team of agents is clean, precise, and totally reliable. And here's the fundamental problem that nervous system has to solve. Large language models, or LLMs, they generate text, but computer programs need structured data. Imagine trying to build a car engine where all the parts are just slightly different sizes. It would be an absolute disaster. It's the exact same thing for AI agents. If the data flowing through their nervous system isn't in a strict, predictable format, the whole system just falls apart. And the solution to this mess? A library called Pydantic. It basically acts as the agent's nervous system by creating a really strict contract. It looks at the LLM and says, hey, I don't care how you phrase it, but the information you give me must fit this exact structure. It's the tool that turns that messy, unpredictable language into these perfectly formed, validated Python objects that the rest of the system can actually trust.
Just look at this simple Pydantic model here. With this little city info class, we are not just hoping the LLM gives us a city's name and population. We are demanding it. We've defined that the name has to be a string and the population has to be an integer. If the LLM tries to send back something that doesn't fit this schema, Pydantic immediately throws a flag. This ensures only clean, reliable data gets through.
So our agent can now think, and it can communicate internally with perfect clarity. That's great, but to actually be useful, it needs to interact with the outside world. It needs hands and feet to perform actions. To call an API, browse a website, or save a file.
But here's the thing, real-world actions are often slow. Waiting for a response from a web server or reading a huge file can take seconds, and in computer time, that is an eternity. A more naive agent would just freeze during that time, just sitting there, stuck, waiting, wasting precious processing power, completely unable to do anything else.
And this is where one of modern Python's superpowers comes into play. Asynchronous code using async and await. Think about it like this. You're cooking dinner. You put a pot of water on the stove to boil. You don't just stand there and watch it, right? Of course not. You start chopping vegetables. That is exactly what asynchronous code lets our agent do. It can kick off a slow task, and while it's waiting, it just switches over to do other useful work.
The concurrency and burgers analogy makes this crystal clear. The synchronous chef is just so inefficient, but the asynchronous model, it's a total game changer. Our agent acts like the cashier, taking a bunch of orders and sending them off to be handled. And the specialized agents are like the kitchen staff, all working in parallel. This is how agents can handle dozens of tasks at once, which makes them feel incredibly fast and responsive.
So our agent can think, it can communicate, and it can act. But to be truly intelligent, it needs one more crucial piece: memory. Without it, every single interaction is the first interaction. To learn and get better over time, an agent has to remember what it's done and what it's been told.
Now, agent memory really comes in two main flavors. Think of short-term memory like your brain's scratchpad. That's the LLM's context window. It holds the info you're working with right now. It's lightning fast, but it's temporary. Long-term memory, on the other hand, is like your brain's library. It's a persistent vector database where the agent stores massive amounts of information it's learned. This lets it recall facts, user preferences, and past conversations to make better decisions in the future. So, we've done it. We've assembled our agent. It has a brain, a nervous system, limbs, and a memory. It's alive. But how do we know if it's healthy? How do we make sure it works reliably before we just let it loose on the world? This brings us to the final and absolutely critical piece of the puzzle: testing.
And here's why testing an AI is so different from testing normal software. If you ask a calculator what 2 + 2 is, it will always give you 4. That's deterministic. But if you ask an AI agent to summarize a report, you might get a slightly different but still perfectly correct summary every single time. And that non-deterministic nature means our old testing playbooks just don't really apply anymore.
So, what do? We use a hybrid approach. For the predictable parts, yeah, we can use traditional tests. But for the quality of the output itself, we use this really fascinating technique, LLM-based evaluation. Imagine a teacher grading an essay. They're not just checking for spelling, they're evaluating creativity, coherence, the whole thing. That's what we do here. We use a powerful model like GPT-4 to act as an expert judge, rating our agent's response for accuracy, helpfulness, and even its style.
So there you have it, the complete anatomy of a Python AI agent. We've got a brain like LangGraph for planning, a nervous system built on Pydantic for reliable communication, hands and feet powered by async and await for efficient action, and a 2-part memory for learning and context. It's an incredibly powerful combination that gives us a complete blueprint for building intelligence.
We now have all the core components, and they're all built on a solid foundation of amazing open source tools. The power to build these intelligent, autonomous agents is officially in our hands. So I guess the only real question left is, what are we going to build with it? The future is waiting to be written.